Okay, this is Mrs. Black, and here we have a 5 kilogram box being dragged along this surface to the right with a force of 100 newtons at an angle theta. The friction is 20 newtons and the angle is 45. It's accelerating to the right because that's the direction that it's being dragged. All right, so we need to find out what all the forces are, and we need to find out what the acceleration is. So, first thing is to draw a force vector diagram. So we have a force push, or pull rather, 100 newtons. We have a gravitational force, which is, we calculate the gravitational force based on the mass. You do not convert mass to force. You calculate it. So that's 5 kilograms times 10 newtons per kilogram, and that's 50 newtons. All right, again, you can calculate gravitational force. You can calculate it based on the mass. What you cannot do is you cannot convert force. The reason why you can't convert mass into force is that none of these other forces that we're going to draw have anything to do with mass. Only gravitational force, because it's a mass-mass interaction. None of the other forces do. So you cannot convert mass into force. This is the weight on Earth of this mass. Weight is a force. All right, so we want the normal force. We want the frictional force, which is perpendicular to the normal, and that is 20 newtons. And then from the tail of the first to the tip of the last, there is your net force vector. Okay, so then this side of this triangle we'll call X. This side of the triangle we'll call Y. Since it's a 45 degrees, it's a 45, 45, 90. So this is 45, this is 45, and this is 90. All right, so what that's going to do is that's going to make this side 1, this side 1, and this side square root of 2. All right, so those are the ratios of the sides. So then to find the normal force, it's going to be whatever this, the whole gravitational force, this big whole thing, is 50 newtons. And so minus whatever this is will give us the normal force. Let's hope we have a big enough value there for gravitational force. I'm kind of thinking that maybe we might not. But we'll see. I might have messed up. So if we do 100 newtons is to square root of 2 as y is to 1, then y is going to be 1 times square times 100 newtons divided by square root of 2, which according to my calculator is 70.7. Okay, so I fixed it because this is 70.7 newtons, which would have been much bigger than 50 newtons. Therefore, the normal force would have been a negative number, which is kind of ridiculous. So I changed this from 5 kilograms to 8 kilograms. Therefore, the gravitational force is 80 newtons. All right, so the normal force will be equal to Fg minus y. So the normal force will be equal to 80 newtons minus 70.7 newtons. So the normal force will be equal to 9.3 newtons, according to my calculator. All right, so we'll put 9.3 newtons there. All right, so now to figure out what the net force is, by the way, again, the net force is right over here. That's the net force right there. All right, so to figure out the net force, we're going to look at x minus the friction will equal the net force. So x minus the friction equals the net force. So that's 70.7 newtons minus 20 newtons. So the net force is equal to 50.7 newtons. Now, why did I give it this, the same value as that? Because they're both 1 to 1, so they got to be the same value. So then calculate acceleration. Acceleration is net force over mass. So that's 50.7 newtons divided by 8 kilograms. And according to my calculator, that would be 6.3 meters per second per second. Now, once again, this says second squared, but we pronounce it 6.3 meters per second per second. This is just a shorthand way of writing it.